When building applications at scale, it is important that you make sure your Docker images are following the best practice. If this is not done correctly, there can be some huge impact, especially from the business side, where you can incur costs, where you can also, affect the velocity of the developers, where maybe whatever changes that they are pushing to production is taking time to build these changes. So it is important that you take a look at some of the strategies that you can use to optimize Docker images. So in this tutorial, we are going to look at 6 strategies that we can use, and I hope you'll find this content helpful, and if so, feel free to like and subscribe. Let's go. Hello guys, this is Tafazwa from StackDev and welcome to my YouTube course. So let's look at trick number 1. So the first technique that we're going to use is called building images from a smaller base. So suppose you have a Node.js application. I'm simply going to create a folder here called Node.js. And this application is a simple Express app. So let's quickly go ahead and build our main.js. And in this app, it's going to look something like this. So this is a simple Express app. You have imported the Express packages and exposed your port, and then you're simply saying hello world. So this is a simple hello world app, which is not basically we are not going to focus on Express in this tutorial. And let's have our package.json. Then inside my package.json file, I'm simply going to copy and paste what I already have. So for our first technique, so like what I've said is we want to make sure that we are building from a base. So let's say we have our generic Docker file that is going to be responsible for deploying this application. And this Docker file, it looks like. So as you can see in this Docker file, we are importing from the node image. And then we are simply declaring that our working directory is the app. And in this case, we are copying the package.json and we are copying it to the app folder that we have declared as our workspace folder here. And then we're installing dependencies and we copy the app and then we run the main.js. So this is a basic Express app. So in this case, what I will simply do now is I'll go to terminal and then I'll quickly try to build this simple Express app. So I'm going to say docker build -t, and this can be a simple Express app with Node, and my Docker file is this. Oh, actually, I need to navigate to the new folder, and then I rerun the command. So as this is building, as you can see, this is a basic Node.js app, right? And we are not using any optimized image in this case. So like what I said, the first technique is we're going to experiment using a smaller base. So let's just quickly see what will be the size of this image. All right, it looks like our Docker image has completed building. Let's now check the size of our image. So if you can check it, the size of our image at the moment is 1.1 gig, okay, which is quite a lot. So how can you optimize this? So like what I've said, one of the techniques is you can use a smaller build, something like Alpine. In this case will work. So let's simply go ahead and use the Alpine Node.js Alpine image. So I'm going to save this, and this is still the same application. I'm not going to change anything except for changing the base to use Alpine in this case. So let's quickly go ahead and clear this. So I'm going to Docker system and to clear my memory, so that we make sure that we are not reusing anything. And then we try to build the same image, but in this case from Alpine. Okay, so here I will say Alpine, and as my tag, then I'll build the same image. All right, this is completed. So if I take a look at the image, you can actually see that this base image has reduced our size from 1 gig to 172 megabytes, which is almost like 90% in reduction, which is huge. So this was the first technique, but this is not always the best. As you can see here in our final image, we are doing building. We are building our image, and as well as build up, binary files in this case, like the node modules folders and everything. And then we are putting it to our final image, right? In as much as this is reduced, but there is another second technique where we can separate the build step and then the actual source code or the running step of our image that we want to mainly focus on, which brings me to the second step or the second strategy, which is called multi-stage build. All right. So for our multi-stage build, I'm simply going to create another Docker file here, which I'm going to call Docker file. Maybe I can call it multi. And then I'm simply going to copy the same image we had initially, and I'll paste it here. I'll minimize this. So from this, the idea of a multi-stage build is you want to separate a build process and the actual production stage or production build of your final image. So the idea is here I'm going to declare this as the build stage, where I'm going to declare my working directory, install my modules here, copy the app. Okay. So this step, I'm going to call it a build step. And then the next step that I'm going to define here is called the production stage. So from the production stage, I'm simply going to use the Alpine base image again. And here I will declare my same working directory, and then I will copy. So I'll copy from, in this case, I'm going to copy from the builder. So actually I need to define this first step as, let's say, build. Okay. So I'm going to copy from the builder, okay, or build. Then I'm going to copy my app and I'll copy it to the working directory. So here, as you can see in this step, what we have done is we have separated concerns here, okay? So in this step here, we have installed the node modules, and once we did that, then we then copy everything into the app, okay? So this step is going to be called the build step, okay? So anything that has to do with building your image, building dependencies, you want to put it in the separate step. And then the final step, you just want to make sure that you put things that are related to the source code or the minimal files that that requires your application to run. Okay, so in this case here, this is what we've done. We are building from the base again, from the Alpine, and then we declare this, and then we simply do this. We copy from the build step. In this build step, we're simply copying the app folder, and then we run it. So if we actually go ahead and build this, so I'm going to go to my terminal. I'm going to run docker build. Then in this case, I can say docker file dot multi, and then I can tag my express as multi like this, and then I'll simply run this. So let's check out the final image. So as you can see from my final image from the Docker multi-step build, it reduced from 132 megabytes to 165. So this is because we've separated the build step and the actual files that we want in this case, which is going to be the main.js and a couple of dependencies that we've already built. So we've separated those processes, and we've seen that the image has reduced size. So just to test this, I can simply say docker run it. So docker run it express sp port 3000. Okay, cool. So I needed to put the port before this, otherwise it will be recognized as something else. So anyway, so let me now try to kill this. Cool. So we can see our Docker mod stage build is working, and this image is actually optimized. So this was the second step of using Docker multi-stage, with the main idea being to separate the build step and the the production stage, where you are actually defining, taking what you only need for your application to run. So that was the second technique here. So the third technique, right? So here you can see we were using this base image Alpine, which is a little bit more optimized than the basic Node.js. Okay. The third step or the third technique that you can use here, it's called, we can use Distroless images with multi-stage like this, but the only difference is we're going to change our image. See you. All right. So for our third technique, we're going to use, instead of using the Alpine base image, we're going to use Google Distroless images. So here I'm on the repository of Google, which they implemented what they call Distroless images. So Distroless images, these are simply images that only contain your application and its runtime. So what this means is these images, they do not have package managers, you do not have shells or anything. It's just a bare Linux kernel without, the things like shells and package managers. Okay, it's the minimal image. And then the idea is you only want to have a Linux kernel where your source code can run into. So for example, the Node.js, Java applications and so forth, they run in a Linux kernel, for example. And then this Linux kernel, we don't want it to have anything, but we just want it to have uh, things that are only related maybe to your runtime environment. So in this case, Node.js, it's a runtime environment, which is used Node in this case. So you only want it to have that. So here, the only thing that we're going to change here is from, instead of using Alpine, we're going to use this Google Distroless image, which doesn't have a package manager or shells, okay, except for the code that we want or for the binaries that we want to run our source code. And they are much more smaller than the Alpine image. So let's quickly go to our VS Code. So in this case, I'm going to create another Docker file here. Okay, so this Docker file, I'm going to call it Docker file. Then I can call it maybe Distroless. Okay, and then in my Distroless image, I'll copy our multi, which we had before. Okay, so from our multi, the only change that we're going to do from this is we're simply going to change the base, okay, the base image, which we used in our production build. So in this case, I'm going to use a Google Distroless image, which is for Node. Okay, they have a specific one for Node.js. So in this case, I'm going to use this one, Node.js Debian 12. Okay, and then the rest of the things, they can actually remain. We need to copy this, we need this as well, and then we need to do this as well. So here, I think I will keep this, but the only thing that is only changing is the base image. All right, so yeah, let's quickly go ahead and try to build this image. So in this case, I'm going to build it like so. So I will use the Docker file. So in this case, this is now the Distroless image instead of the Alpine as my final image. So here I will say express distro, and I'll build this. It's supposed to be in the Node.js folder. Let's try one more time. Okay, so this is the Distroless now. It's building. All right, so this is completed. Now let's run Docker images. So here you can actually see that from our Distroless image, our image is further reduced from 165 megabytes to 156, which is also huge. So here the idea is, yes, you're using the recommended Docker multi-step build, but in this case, instead of using maybe a base image like Alpine, you can actually go ahead and use a more optimized Distroless image, which doesn't have a shell or a kernel, a shell or any package manager. It only has things that are related to Node.js only. Okay, and then the final image that will be used here will be this production stage image, and you can see that it has reduced size from 165 to 156. So this was the Distroless approach, which is also important, whenever you want to optimize images. There are other benefits of using this, which include security. So the idea being, you are not installing other kernel, other package manager related things that might not be necessary for your application, which might bring, some security concerns. For example, if the packages or these packages are not updated. So the idea is you want to use, as the first rule of thumb for security, you want to make sure that you use the minimal possible kernel base for your application. So that whenever there are security concerns, you only know that you are looking at Node.js related things. You are not looking at other Linux distributed things that might not be within the scope of application. So Distroless images are recommended. They also address a lot of security concerns. So I'd recommend you to use this technique. So the rest of the techniques that we are also going to look at are going to be dependent from this. Which brings us next to our sponsor. So the sponsor of this video is called Compexus. I will quickly show you what Compexus is all about. It's a great tool for managing your projects. Should you be interested, use the link down in the description of this video. There's a link there with a token, StackDev.io, and you get 60% discount on your next buy. And then you also get 14 days free license.
Welcome to Compexus. Thanks for being here. I'm excited to show you how this all-in-one project management and OKR platform can make your team's life so much easier. Let's start with stories. Think of stories as your everyday tasks, bite-sized pieces of work that move your projects forward. You can create a new story in seconds, give it a title, assign it to a teammate, set a due date, and even tag it with labels like bug or feature. Once your team starts working, you'll see stories move across your board in real time, so everyone knows exactly what's happening. Next up, objectives. Objectives are your big picture goals, the things you want to achieve this quarter or year. In Compexus, you click New Objective. Give it a name like Improve Customer Onboarding. Add a target date. And describe what success looks like. Objectives sit at the top of your hierarchy, giving context to every task your team tackles. Under each objective come key results. Key results are the measurable milestones that tell you if you're on track. Say your objective is improve customer onboarding. Your key results might be reduce time to first value to 2 days, or achieve 90% completion on the onboarding tutorial. As you finish linked stories, Compexus automatically updates the progress bars, so you get real-time visibility into how you're doing. Now, on to sprints. If you work in Agile, setting up a sprint is a breeze. Hit New Sprint. Choose your team. Name it, like Sprint 1, Feature Rollout, and set the dates. Then drag stories from your backlog into the sprint. Switch to board view. And you've got a Kanban-style setup where you move cards from to do, to in progress, to done. Everything syncs instantly, so there's never any confusion about who's working on what. One of the best parts of Compexus is that you can customize terminology to match your process. Prefer to call sprints iterations or stories tasks? No problem. Go into settings and rename any entity. This way, Compexus adapts to your team's unique workflow, not the other way around. Ready to see it in action? Head over to compexus.app for a free trial and discover how stories, objectives, key results, sprints, and custom terminology all come together in one powerful platform. Compexus, where strategy meets execution.
All right. So we are now going to talk about the fourth technique that you can use. So far we have discussed 3 techniques already. The first one was you need to use a smaller base, where we looked at maybe an Alpine image as a base. Then we looked at multi-stage build, which is the recommended best practices whenever you are building Docker images. You need to make sure that you are separating the build steps as well as the final step of your production stage, which is the final Docker image. And then we talked about using Distroless images, which addresses issues of security concerns, and as well as, it's even better than a smaller build, because these images are only targeted to your environment that you want to run your application. So if it's a Node.js application, Java application, you are only using these Distroless images that only have binaries that are only related to that specific environment. And then our fourth step that we're going to look at the docker ignore file. So the docker ignore file is very important. This is a file that you need to define all the time actually in your project, so that you make sure that you don't necessarily ship things that are not related to your source code or to the business logic of a source code. So in this case, I will show you. So let's say I'm going to create a Docker. So this is my Docker ignore file. So inside this Docker ignore file, so here you can actually see that here from our build stage, we're copying everything from the app. And then this app, it also included things like the node modules folder. So in this case here, in my Docker ignore file, it's like the Git ignore file. If you're familiar with Git, we will want to include things that we don't necessarily need to push. So this can even include environment variables, secrets, and so on. In this case, I've included the node modules folder, Git, and also the log. So this will exclude all these binaries from our final application. So depending on your business logic, you might also have other files that might not, have impact to the running of your application. You need to add them in the Docker ignore file. Okay, so this is the fourth technique, and you should always use it. So with this this I don't think it will make much difference, but let's simply try and run our Distroless image we had before. Okay, yep. So in this we can see it's still at 156. Okay, so this was the fourth technique. Then the fifth technique that you can also use is you can use a technique called minimizing layers. So with Docker, let's take a look at this Express distro image. So if I say Docker history, I want to take a look at the history of this distro plus image. You can actually see that we have layers here that our Docker have been used, and all these layers basically have basically some memory or some space that is taking up to the final build of our image. So the idea is you want to make sure that, because in Docker, each and every command that you're writing in Docker is going to cause a layer in Docker. So for example, here, our last command here was to run. You can actually see that this is a layer of size 0 bytes. It's 0. But the previous step of copying everything to the app, it has a size of 2.21. So this is also extra space, including this workday step here. It also has, some it's 0 bytes, and then some other missing layers that maybe were coming whenever we're building maybe the Alpine image. So you can actually see that sorry, it was actually this. You can actually see that so this is the third step, this is the last one, and then the other layers here that are saying hidden were from this whenever we're importing the Distroless image. So these are the other layers. So you can imagine that if we have so many commands or so many copy commands or run commands in your application, this can also contribute, to the final size of a Docker image. So you need to make sure that you try by minimizing this. So one of the techniques that you can use to minimize layers is to make sure that things that are related. So for example, if you have a run command, you need to make sure that you put it, in one command instead of running separate commands. So for this, to demonstrate this, let's assume that maybe we have a custom GitHub runner, for example. And then this custom GitHub runner, it has maybe a folder called config. And then inside this folder, there is some like, I don't know, config dot text, yeah, for example. And then I'm going to create a Docker file now for this. Okay. So I'm going to create a Docker file for our runner here. So inside our Docker file, this is our Docker file for our runner. This Docker file, it's simply an Ubuntu image, which we are installing a couple of things. We are updating, we're installing Kale, we're installing Git, and then we are cleaning at the end, just to make sure that we clean the cached stuff. Also, it also helps in reducing the size. And we're also removing some cached stuff as well here. This is also reducing to remove some cached things. And then we copy this to our app. We copy the config. We have to copy commands, and then we run bash. So this is a basic Ubuntu 22 base image. Okay. And then let's say you are using this base image for your GitHub runners or anything that you might want to use this image. So now let's try to demonstrate how this will work. So let's say I'm going to clear my memory now. Docker system prune. I'm going to clear all the cache so that we just make sure we don't have anything. Okay. So if I say Docker images, sorry, Docker images, we have nothing. Oh, still have an image. So let's try to clean this up. Okay. Docker images. Why is this image still running? So Docker PS, maybe there are okay, there's a container running here. So let's quickly run this container. Docker remove. Let's delete this container. Docker PS. Then okay, okay. So we are now clean. We no longer have any image. So let's try to build this image. Docker build. Then I can call it Ubuntu 22 or something. Okay. Oh, all right. I need to navigate to the runner folder this time. Okay, let's try to run it. Oh, okay, so here it's complaining about app. So maybe I'll create something like an app here. Right. So if we say Docker images, you can actually see that we've built our image and it's 204 megabytes. Okay. So now let's try to take a look at the history of this image. So if I say Docker history, then I take the image ID, then I run it. You can actually see that from this image, okay, all these steps. So for example, what I said about reducing the number of layers, all these steps, they are layers, okay, in a Docker image. And all these steps, they have some memory implications. So you can see that here, you can see like when we build, when we update here, it's the update is taking 58 megabytes. The install is taking this much of memory. This one is taking this much, and this all this contributed to the 204 megabytes that we can see here. So what reducing layer technique does, okay, is, which is our fifth technique, by the way. What this technique does is you want to make sure that all these run commands are only being done by one run command. So you need to encapsulate all this to one command. So now let's quickly go ahead and create a new image. I can call it Docker file. I can call it Docker file, then maybe dot layers like optimize layers. And then instead of running all those separately, I'm going to encapsulate them to one. So you can see here, so all these run commands, which I said they're layers, I've encapsulated them to one command by simply putting an end, and then we put an end of line here. Then we install this curl, we install curl, we install git, we put an end, we install clean, and so all these commands that were separate is now one layer. So now let's quickly go ahead and run this image and see if it is reduced the size of this image. So before, the size of this image was 204. So now let's build this. So here I can say Ubuntu, I don't know, I can say layers like optimize layers. Then I can say file in this case. My new Docker file is called Docker file layers opt, like so. Let's pick this guy. So the idea is the number of layers are going to reduce by the how many this number of commands. So they're going to reduce by 3. Okay, and this should significantly reduce the memory size, the Docker size of our final image. So let's see. All right, so it's happy. So let's quickly go ahead and take a look at the images. So you can see that the image has reduced from 204 megabytes to 144, which is significant. And we didn't do anything fancy here. What we simply did is, instead of having these run commands as individual commands, we have only encapsulated them to one command. And then we add an end here. Okay, like just run, install everything in one command. And you can actually see the benefits of this. So this is also something that you can also take a look in a Docker images. If you have run multiple run commands or multiple copy commands, you need to make sure that it's only being handled by one command. And this will significantly reduce the memory size as demonstrated. So this was our 5th step. If you're enjoying this tutorial, please make sure you like and subscribe so that you won't miss the future videos. So the last technique of this tutorial that we're going to look at is we're going to look at using what we call a scratch image. Okay, so Docker already has something called scratch images. So let me just quickly jump to Chrome. Okay, so in this case, so if I say Docker scratch, so a scratch image is again a distroless image, just like Google. The only difference with the Google ones is the Google ones are only specifically targeted to a specific environment, should you want. But this one is the idea of saying you want to build your images from scratch. This is, you are simply given a Linux kernel with nothing installed, no shell, nothing, just like our distroless images. So these are true distroless in the fact that, in the sense that it doesn't have even a runtime environment for an application. So you would want to do it from scratch. It's kind of an advanced feature, but it's also worth a while trying. And one thing that you should note about these scratch images is they only work for applications that have self-contained binaries. Okay, so these are applications that gives you a binary executable. So maybe in Java Spring you can use, so instead of using the OpenJDK, I have a tutorial for this. You can use GraalVM in Java. It produces a native executable, and you can simply run it as a binary file. Okay, and then you can also use it maybe in Go. Go produces a native executable, Rust, C++, so those kind of languages or technologies. So this is where you can apply this. So a scratch image, simply a distroless image again, with no shell, no package manager, just a bare kernel with nothing, literally. And you can't really SSH into it because it doesn't have SSH installed, for example. And so I will quickly demonstrate how you can use this, maybe using Go, for example. So let's quickly jump in. All right. So suppose you have a Go image. So a Go application, I'm simply going to create a new folder called Go. And inside this folder, I'm simply going to create my simple Go application. Maybe I'll paste this. So I have my main.go, it simply prints hello world. Okay. And I'm going to create a simple Docker file like our multi-stage build, which is optimized. So you can have a multi-stage build like this. This is what we have already discussed. So in this case, you can use a distroless from Debian, from Google in this case. So this is the same idea like what we had before. But now the idea is, in this case, I'm going to create another Docker file now. Instead of using the Google distroless, we want to use the scratch. So here I'm going to say Docker file dot scratch. I don't know why my IDE, if I put scratch, it's not recognizing it as a proper Docker file. Anyway, so I will do this. So for my Golang application, I'm downloading the modules. I'm running the tests. In this case, I have a test Go file. And then this is exactly what we've explained. You only need to do this in the build step. Okay, this is a multi-stage build technique. And then instead of using a Distroless like from Google here, we are using a Scratch image from Docker. And this Docker is also a Distroless image, but it has nothing as well, just like the Google one. The only difference is this one doesn't have even any Go related things. So here we simply want to copy the native executable that we get from our build step, and we simply run it. Okay, so if I am to save this, okay, so let's run our first mode stage so that we see if there's going to be a difference. So here I'm simply going to navigate to Go. So I'm going to say Docker systems. In this case, I will delete this. Just making sure I have nothing. Okay, so here I'll say Docker build -d. Say Go. This is like the Distroless one. Go Distroless. So this is going to build the image from our Google Distroless. We want to see the size and see if it's going to make a difference. Right? So it looks like our build is completed. So if I say Docker images, you can actually see that this is a significant 3.94 megabytes from using the static Debian 12. So let's simply try, let's go ahead and build the Go one and see if there's going to be a difference. So I'm going to clean up my cache and I'll build the Go one. So this is a Docker file. I'll use the Scratch. So Scratch, how did I spell Scratch? -t, Go Scratch. Okay. All right. So it looks like it's done. So let's check out the size of the Scratch now in this case. So Scratch is now even a significant 1.95 megabytes from 3.95 from Google. So you can actually see that the Scratch is significant. So let's try to run this sketch just to make sure. So if I say Docker run it, and then we say Go, in this case we're using the Scratch tag, and let's run this bad boy. Okay, misspelled Docker. Boom, it worked. So you can see it has run our Docker image. So Scratch Distroless base images are quite powerful in the sense that they eliminate almost all security concerns that are related to to your kernel that your source code is running to. Of course, it won't eliminate things like bad practices in your source code, but at least you are somehow protected from the Linux distribution that your container is running to. And I would recommend you to use the Scratch images, especially if you don't want to do things like debugging where you don't necessarily want to SSH into the container, for example, because here you don't have a shell or anything. Maybe you might need to, in Kubernetes, you might use other techniques. For example, init containers where you'll be putting logs maybe somewhere. And you only make sure that your application is only running as a binary file in a minimized container. So Scratch images are quite powerful, and of course, with great power comes with great responsibility. So that was it for this tutorial. I hope you found this information informative. And if you have any questions, I will link the repository in the GitHub. So feel free to go to my GitHub. I'm going to push this code just after this tutorial. Feel free to go this. Thank you guys for watching, and don't forget to like and subscribe and share this video. I will see you in the next one. Cheers.